Differentiating x to the power of n where n is a negative integer is what we're going to have a chat about today. What you need to be aware of with these is you need to consider what's going on with the domains with these. So in these particular cases, the domain is going to be all real numbers except it cannot be 0. So we do need to start using this notation where we have negative integers. This first example, they're asking us to do it using first principles. And to actually get from sort of this step here to here, I wanted to show you how we go about doing that. There may be some confusion as to what's going on here. So I just wanted to show you this a little bit differently. So let's have a look here. Alrighty, this is a little bit different year 12 methods, guys. We're looking at differentiating x to the power of n where n is a negative number. Now, this first question requires you to do it using first principles, and I just wanted to go through the first step of worked example number 14, just so that we were all cool with how they actually got to where they were going. So here's how I believe they got to the first part of this particular question. In this particular case here, we've got f of x is equal to 1 over x to the power of 3. So just writing it using positive powers. If you have, again using first principles, f of x plus h, it's going to be 1 over x plus h cubed. People should be fairly happy with that. And obviously, to work out using first principles, f dashed x, with the limit as h approaches 0, what you're going to have is this here, f of x plus h. We're going to write it as 1 over x plus h cubed. Take away f of x, which is 1 over x cubed. Yep. And that was all over h. Yep. So that's just using first principles for differentiation. Now, when you are dealing with fractions here, so that they have the common denominator, we need to rewrite, so it's got a common denominator. You can just multiply things that are on the bottom of these fractions. So we need to multiply this here by x cubed. I'm just going to put a little dot there. What you do to the bottom line, you need to do the top line, so we need to multiply that by x cubed. So that will be the common denominator there. Obviously here we need to multiply this by this over here. So we're going to multiply that by x plus h cubed. We need to do the same thing to this line on the top. x plus h cubed. Like so. Now, simplifying things down, here you've got all of this is divided by h. Now, you could write it out as divided by h, which is h over 1. But rather than writing all of this out divided by h, let's consider changing this dividing by h over 1. We'll multiply this top by 1 over h. Yep, so again, let's simplify down this top here. So on the top line, this is just this part of the fraction here. We're going to have, on the top line, we've got x cubed. 1 times x cubed is x cubed. Take away 1 times x plus h to the power of 3, which is that. And that is all over, the common denominator here is x plus h cubed multiplied by x cubed. Now again, rather than dividing this by h, as we said, dividing by h over 1 is the same as multiplying by 1 over h. So if we multiply this all by 1 over h, it's just a lot neater than rewriting all of this divided by h there. So hopefully this is cleared up how they got to this particular stage so that you can continue down with worked example number 14 using first principles. A little bit different. Okay.
Year 12.
So it looks like I should have had an equal sign there as well. Oops. But as you can see, we got to this stage here by using that technique. Hopefully from there you can follow along, obviously expanding things out, grouping like terms and simplifying things down. From here we can see that we do get to the derivative of negative 3 x to the power of negative 4 from that. Alrighty, let's have a look now over the page. And again, we're still applying the same rule as we were in the previous exercise, where we're finding the derivative f dash x, we're subtracting 1 from the power, and obviously we're multiplying by n at the front. Don't forget also the derivative of a constant is 0. So here, worked example 15, should be no surprises here with this. Obviously we've got a negative power here, we've got a negative power here. Multiplying this power by the value in front, we get negative 3 multiplied by negative 2, which is positive 6. Subtracting 1 from the power, we end up, if you're at negative 3 and you subtract 1, you're at negative 4. Most common mistake here with this is where people forget how to subtract 1 from negative numbers, and that causes all problems there. Yep. So just remember your number line here in methods. Likewise here, negative 1, we're multiplying that by 1 at the front, which is negative 1. Subtracting 1 from the power, we end up at negative 2. Yep. Again, next question, same difference here. Negative power, negative 2 multiplied by negative 6 is obviously positive 12. Subtracting 1 from the power there. Okay. This one here, it says here, find the gradient of the tangent to the curve determined by the function. Now, we know that 1 over x can be written as x to the power of negative 1. Yep. Once you change 1 over x, put this back on the top line, change its power. This here is x to the power of 1. Goes back on the top line, change it to a negative power. We can then apply the same process as above. So the derivative of this part here, obviously you've got the negative 1 goes out the front. Negative 1 multiplied by 1 is negative 1. You subtract 1 from the power, which becomes negative 2. Yep. They're also asking, hey, what is the gradient at this particular point? We substitute in the x value back into the derivative, and you can find out what the gradient is. In this particular case, the gradient is 1 at that particular point. Last but not least, it says here, show that the derivative of the function f of x equal to x to the power of negative 3 is always negative. You can see here we calculate the derivative, which we know how to do. When you've got a negative power, it can be rewritten nicely on the bottom line as a positive power. And actually just stating here, since x to the power of 4 is positive for all x not equaling 0, then we've got the derivative f dash x is going to be less than 0 for all of these values where x is not equal to 0. Yep. So where x is not equal to 0, any number that's down here, it's going to be a negative number for that. Cool. Thank you very much for listening up. Have fun with exercise 9C. Bye for now.